All right, so a lot of words. Let's take a look at this question. First, let's identify what they're asking us to do. So we're looking for calculate, how many, determine, and there are two questions that are asked here. How many molecules of saccharin are in the sample, and how many carbon atoms are in the sample? What we're given to get to these answers, our starting point, is our mass of saccharin. In order to go between mass and ultimately number of molecules or atoms, we're going to have to go through moles. So the general strategy is that we're going to start with the mass, get to the moles of saccharin, then we can use Avogadro's number to determine the number of molecules, and then as for the second problem, we can go from the molecules to the number of atoms of carbon using our chemical formula. We have this form of a general formula, chemical formula, and we also have the structural formula. The structural formula is nice, but we don't need it. We could, if we weren't given this form of the chemical formula, we could translate this to this, but for now, we're just going to ignore this because it's not something that we need. Note also that we're given the formula weight of this molecule. So don't waste time calculating formula weights in problems where you're given the formula weight. Since we have the formula weight, we know we can write two versions of a conversion factor. 183.18 grams is equivalent to a mole of saccharin, and we know that a mole of saccharin is equivalent to 183.18 grams of saccharin. So now let's go to a statement of the question to figure out what version of the conversion factor we need. Well, we're given our mass as 0.0400 grams. We're going to multiply it by a conversion factor to cancel out units of grams. So we're going to need this conversion factor. 183.18 grams is equivalent to a mole. So we can see that our grams cancel out, and we've gotten to moles of saccharin. Next, we want to get to the number of molecules of saccharin. We're going to be using Avogadro's number as a conversion factor, 6.022 times 10 to the 23rd. And this, since we're dealing with compounds, this is the number of molecules of saccharin we have in a mole. So we can write two different conversion factors, 6.022 times 10 to the 23rd molecules is equivalent to a mole. And we can write that a mole is equivalent to 6.022 times 10 to the 23rd molecules. Looking at where we are in our calculation, where we have moles and we want to get to molecules, so we're going to use this first version of the conversion factor to get to molecules of saccharin. So every mole of saccharin is equivalent to Avogadro's number of molecules. So now we can see that grams cancel and moles cancel. So we have arrived at the number of molecules. So the number itself, we can get to our calculator answer by dividing 0.0400 by 183.18, then multiplying by Avogadro's number, and we get our answer as shown. Let's look at sig figs. We have 3 sig figs here. Those two trailing zeros count. The initial leading zeros do not. 5 sig figs, 4 sig figs. So we can only report our answer to 3 sig figs. We're going to have to round down. Our final answer for molecules is 1.31 times 10 to the 20th molecules. Okay, so that's our first answer. Now we want to find out the number of carbon atoms. And we need to look at our chemical formula here because we know every molecule of saccharin is going to have 7 carbon atoms. Every molecule, every unit is going to have 7 carbon atoms. We're going to start with our unrounded answer in terms of the number of molecules. So we have 1.31499 times 10 to the 20th molecules. And we're going to multiply that by 7 carbon atoms per molecule. And that's what we get from our chemical formula. If we multiply those two numbers together, the answer I get is 9.2049 times 10 to the 20th carbon atoms. We need to worry about sig figs next. So we look at all the numbers that go into the answer. We go back to our unrounded number, and our unrounded number, we use the whole thing because we don't want to round until we get to the end, but we know it really can only justify 3 sig figs here. 7 carbon atoms per molecule is an exact number, so that's not going to impact our significant figures. A way to think of it is it has an infinite number of sig figs. So we look at our final answer. We can use 3 sig figs. We drop that 4. And our final answer in terms of carbon atoms is 9.20 times 10 to the 20th carbon atoms.